Section 2.3, Fraction Basics. In this section, we will start working on different fractions. So, what is a fraction? It's a number written in the form a over b, where a and b represent whole numbers, but b does not equal 0. Remember, we had talked about that earlier, that the bottom number cannot be equal to 0 because division by 0 is undefined. So let's talk about a couple of other terminology words having to do with fractions. First of all, if you have the fraction 3/4, the top number is known as the numerator. And the numerator refers to how many of the parts of the whole you are talking about. The bottom number is known as the denominator. And the denominator refers to how many parts the whole is divided up into. So, if we wanted to draw a picture of the fraction 3/4, we could have a circle. It's not the greatest circle I drew, but you get the idea. Divide it into 4 equal pieces and shade in 3 of those pieces, which shows the fraction 3/4. There's another way, in picture form, to show the fraction 3/4, because fractions can also be used to name a part of a collection or a set of identical objects. So notice here I have 4 different squares drawn, and I have shaded in 3 of those squares. In this particular case, the 4, the denominator, refers to the total number of objects, while the 3, the numerator, refers to the number of objects that are shaded. You can think about fractions being represented either one of these 2 ways. How about the fraction 5/4? Well, remember, the bottom number, the denominator, says how many parts the whole needs to be divided up into. So I still need to divide the whole thing up into 4 equal pieces. But I need 5 pieces. So what I need to do is I need to have another whole piece. And now I can show 5/4 by shading in 5 of those fourths. That leads to another important fact here when we're dealing with fractions. 5/4 is known as a special type of fraction. It's known as an improper fraction. Now, truthfully, there's nothing improper about it. I wish they didn't use that term, improper. All an improper fraction is a fraction in which the numerator is larger than the denominator. But there's another way to write an improper fraction. An improper fraction can also be written as a mixed number. So I take a look at this improper fraction that I have, and I can see by the picture that what I have is I have 1 whole circle and 1/4 of another circle. So as a mixed number, this is the same thing as 1 and 1/4. In this course, you do need to be able to change from an improper fraction to a mixed number. And you can go through, if you want to, and you can draw out what an improper fraction looks like. Here I have 5/3, so I'm going to divide each of the wholes into thirds, and then I'm going to shade in 5 of them, which shows as an mixed number I have 1 whole circle and 2/3 of another number. But that gets laborious after a while. There are other ways to change 5/3 into a mixed number. One thing you can do is you can say to yourself, well, I know 3 of those 5/3 would be equal to 1, and I would have 2/3 left over if I took 3/3 away from that 5/3. So it would be 1 and 2/3. Maybe you remember the other way of doing it. 5/3 I could change that into a mixed number by dividing. Remember, 5/3 means 5 divided by 3. So I could do the algorithm, the division algorithm. 3 goes into 5 one time. 3 times 1 is equal to 3. Subtract, I get 2. So I have 1 whole and I have 2/3 of another. So it's equal to 1 2/3. It doesn't matter which way you do it, you just want to make it efficient. Let's change one more improper fraction into a mixed number. Here I have 19/4. This one I am just going to go through and I'm going to do the division algorithm. I have 19 divided by 4. How many sets of 4 are there in 19? Well, there are 4, because 4 times 4 gets me closest to 19 without going over. 4 times 4 is equal to 16, so I have 3 left over. So, as a mixed number, 19/4 is equal to 4 3/4. One other skill that you need to be able to do in this section is to change from a mixed number into an improper fraction. So here I have 1 3/5, and I want to change that into an improper fraction. Once again, there are all sorts of different ways of doing it. One thing you could do is you could say, well, I know that 1 is equal to 5/5, because if the numerator and the denominator are the same, that's equal to 1. So 1 is 5/5. I also have an additional 3/5. I add those together and I get 8/5. So 1 3/5 is equal to 8/5 as an improper fraction. Another way you can do this, and perhaps you remember this from earlier days, if I have 1 3/5, I know I need to deal just with fifths. And I could go through and I could multiply. 5 times 1 gives me those 5/5. But 1 times 5 or 5 times 1 gives me 5. So I'm going to multiply that and then I'm going to add 3 more fifths. 5 times 1 is 5 plus 3 gives me 8. I'm still dealing with fifths. So the answer is 8/5. Let's do another example. To change 7 3/10 into an improper fraction, I'm first going to multiply 10 times 7. 10 times 7 would give me 70. Then I'm going to add the 3. So I get 73. So the final answer to this is 73/10. Now, remember, I multiplied 10 times 7 because what I really have is I have 7 circles, and each one of those circles could be divided up into tenths, which means that I would have 70 tenths, which is what I get when I multiply 10 times 7, and then I just add the 3/10 to that. Here are two problems similar to the homework that you have in this section. In the first problem, you need to change to a mixed number. In the second problem, you need to change to an improper fraction. Why don't you pause this for a moment, figure out the answers, and then start it back up again, and I will go through what I might do to get them. Okay, hopefully you've had a chance to go through. I have 27/8. Probably the simplest way, the most efficient way, is to divide 27 divided by 8. Well, how many sets of 8 are there in 27? There are 3. 8 times 3 gives me 24. I'm going to subtract. I'm going to have 3 left over. So the answer as a mixed number is 3 3/8. For 10 2/5, I want to change that to an improper fraction. I'm going to multiply. 5 times 10 gives me 50, and then I'm going to add 2. So I get 52/5 as an improper fraction. Another way to look at fractions and mixed numbers is on a number line. So you can see in this picture I have a number line just from 0 to 2. And I have 2 marks on it, point A and point B. The question is, where is point A on this number line? You can see that the very beginning of this line from 0 to 1, from here to here, is divided up into 4 equal parts. And that dot A is on the third part. So the position of point A is at the point 3/4. As far as the B goes, it's beyond the 1. So I do need to put in the number 1. That's the whole number. And then once again, from 1 to 2, it's divided up into 4 parts. And B is at the first part. So this is at 1 and 1/4. Another way you could say that is that B is also at 5/4. If you wanted to do that, you could, because this is 1/4, 2/4, 3/4, 4/4, which is equal to 1, and that's 5/4. So we could write it one of 2 ways, either as 1 and 1/4 or 5/4. Here's another number line dealing with fractions. It says to plot 2 1/2 and 1 3/4 on that number line that is pictured. So I have 2 1/2, but notice in between each one of these integers from 0 to 1, from 1 to 2, and from 2 to 3, the line is divided up into 8 different parts. There are 7 ticks, and that divides it up into 8 different marks. So if I want to put a dot at 2 1/2, I need to come beyond the 2, because here's the whole number 2, and I need to go halfway between 2 and 3. If it's divided up into 8 different parts, half of 8 is 4. So I need to count over 4, 1, 2, 3, 4. And here's the point 2 1/2. 2 1/2 would also be 2 4/8. It would be exactly the same thing. If I wanted to plot 1 3/4, once again, I need to come beyond the 1 mark, and I want to plot it at 3/4. Once again, it's divided up into 8 equal parts. So I need to change that into 8 equal parts. 3/4 is exactly the same thing as 6/8. So I would need to come over 1, 2, 3, 4, 5, 6, and this would be the point right here, 1 3/4, which is exactly the same thing as 1 6/8. I once had a student tell me, math wouldn't be so bad if it wasn't for those stupid fractions. I know many people do experience difficulty in working with fractions, but they are so important, not only in this course, but also in many applications in real life. Please let me know how I can help as you work through this section.